Okay, so could you tell me about what your goals are and what you hope to get out of these sessions?
Uh, okay, so my main goal is to prepare for the Polish Informatics Olympiad. And in these sessions, I hope to develop a better problem-solving mindset, like learning how to approach a problem when I have all the theoretical tools, but I don't know where to start really.
Okay. Could you give me some
Okay.
examples of theoretical tools?
Like I know some of C++ and Python because the main language of the Olympiad is C++. Uh,
Okay.
I don't know how to show you what level am I at.
Okay. But have you been practicing? Have you already started?
Yes, I have been practicing sometime.
Okay. How long have you been doing this for?
Like a year or so.
Okay. Let me think about this. What's your preferred language?
C++
C++.
right now.
Okay.
Yeah.
Um, I think to first, for you to get the most value out of this, I think I need to figure out where you are at first.
Okay,
Is
I
it
can
okay if I
show you.
give? Oh
Yeah,
yeah.
yeah, okay, of course.
Wait, what can you show me?
I can show you what I don't know. My current task was at the
Okay.
Olympiad. I don't know. I'm working on graphs right now and currently on trees.
Okay.
Okay. Uh, there was this task where you had some principles and you had to check if the task would go to the top to the main principal if it was not blocked. Yeah, I don't know how to say that, sorry.
Okay. No, that's fine. I roughly understand what you mean.
Okay.
Okay. I know, I see where you're at. Okay. But you say that you have a theoretical foundation, but you want to improve your problem solving skills. What kind of
Yeah,
problems do you face with problem solving?
uh, I really don't know where to start. Like when I have a task, uh, yeah, I don't know where to begin at. I don't have like that mindset when like people just go and draw some things and they know how to write code for it.
Can you give me an example of a problem that you had trouble with?
Okay. This one was tricky for me. I can show you. This is in English, so it
Oh,
will
yeah, can you
be
send it to me?
yeah, of course. Email or how? Chat?
Zoom chat will do.
Okay.
Okay. Could you walk me through how you'd solve this problem?
Uh, okay, I must read it first. I don't remember it. Sorry.
Okay, yeah.
Uh, Yeah, okay. I know, I know that. Okay, I have some code written up. Okay. Okay. I know that. Maybe we'll delete it. Okay.
Okay.
Okay. That's great. I know that we need to have some range and we need to swap the cows. Yeah. But this is too many tries to do it like every time, yeah? So we need to uh, do like modulo. I don't know how to say that, but I don't know uh, of which number, yeah?
Okay.
I know we need to do something with the k times because the k times is way too much. It won't be in, I don't know what is the time limit for that. Probably 1 second.
Hmm.
Yeah, but if you have something you want to talk about, we can do something else. It's not necessary to do this.
Yeah, my main goal right now is to understand where you're at because I'm not sure
Okay.
where to start you off. Okay, why don't we start with this? Okay, but I will say though, like programming, like regular programming is very different from programming for Olympiad. Like
Yeah,
Olympiad, you need to
I know
like,
that. I know that.
so I might say things that are actually contradictory to what you should do in an Olympiad. For example, I might say like, oh, can you come up with the a brute force solution first? Like come up with a
Yeah,
solution that's not very good.
yeah,
Yeah. So
like
like
a
I might
brute
say that,
force. Yeah, okay,
but you wouldn't
okay.
do that in a real competition, right? Because you'll be
Yeah,
wasting time. Yeah. So okay, for our purposes, can you come up with just an obvious solution? Because I want to see how you think, how you like
okay,
write the
okay.
code out.
With like a brute force solution for this.
Yeah, so explain to me like, okay, first come up with a obvious solution. It may not be good, but at least we'll get the job done and explain to me how you come up with that. So could you live code in front of me now?
Yeah, of course. Uh, okay, so in the first place, we need to like get all the numbers, yeah? What
Okay.
are the numbers? Uh,
Wait, can you
okay,
split
okay.
screen?
Oh, yeah, of course.
Yeah, I think that'll make our lives easier so you don't have to keep going back and forth.
Yeah.
And then you
How
can close
to,
your file system as well, like the Explorer.
yeah, yeah, okay. How to like scroll? This is not half screen. Okay, sorry.
You're on Windows, right? So you should, oh yes, perfect.
Yeah, yeah, okay. It's good. Okay, and what we have to do for each line contains percentages.
Well, I have a genuine question. So this is not a rhetorical question. It's like I'm genuinely curious. Why
Yeah,
do you
okay.
use long long for NM and K?
Uh, I don't know. I really do it because uh, okay, this is for sure. This wouldn't pass the integer, but I don't know why not. The memory limit is not that strict as the time limit, so I don't have an explanation.
Okay, no, that's fine. I was just asking.
Okay, okay. Is it a bad thing?
No, no, no. I just want to like
Okay.
I wanted to see. Are you like autopiloting writing long long, or are you thinking about it? That's why I want to ask.
No, no. I'm
Okay.
just. I did many things when I did long. I don't think about it. Yeah.
Okay, sure,
I
no
just
problem. It's okay.
do it.
Oh, also, I have another question. This long long, like, did you write this, or is this given by the competition?
All of this.
Yeah, yeah.
Yeah, yeah. No, no, it's right by me. This
Okay.
is my things, yeah.
Okay, that's fine.
That just makes my job easier, yeah.
No, no, I understand. That's good.
Yeah, okay. Uh, I'm sorry, I don't know how to focus if if you are in the meeting, sorry.
It's okay.
Okay. So we're going to do that k times. Um, mm, okay. You can just use a for loop to like fill the first vector out, but we don't need to use a vector. Yeah. That's I like uh, why my code is all messy. Yeah.
That's okay.
Uh, like in school, we don't learn about the way to learn for the Olympiad, but just the like object-oriented programming like classes, you know.
This
I'm
is
just
fine.
uh, I'm just learning this for myself. Yeah.
Oh, that's okay. You know, this is perfectly fine.
Okay. Uh, yeah. What else the okay. How many times? Yeah, I think so. But this needs to be like this. Ah, what I'm doing. I just swapped from like Python, so it's hard for me to write in C++.
Yeah, that happens sometimes.
Yeah. Uh, what's scene? Okay. Uh, mm, okay, so we need to reverse it right now, yeah? I think so. Uh,
Okay.
mm, mm, why I use int right now? Can I do it like this? I don't know.
Why not?
Mm, uh, of oh, because if L is not like uh, zero, how would I know what like the end, the last one is?
No, what does the problem statement say?
Like we need to reverse the array from the uh, index L to the index R, yes?
Okay.
So yeah, I think there's a function for that built-in, but I don't know what it's called, like probably reverse. But that would be, yeah, maybe in algorithm. Uh, it takes like what it takes. Sorry. Listen to um, yeah, I don't know how to use that function, so I won't use it. Mm. Yeah, I don't know how to do that really.
Okay, let's pause here for a second. Can you explain line 27 to line 41? That the
Uh,
double for loop? Can you explain what it's doing?
yeah, because we need to swap. Yeah, okay. For each okay, m times we will receive numbers L and R, uh, and we need to swap the array from index L to R. I don't know how to say that letter R. Okay,
Yeah, that's correct. Yeah.
and we need to do that k times. We need to
Okay.
do the same
We
thing k times. Yeah,
we need to perform the instructions k times, but how many times do we need to read the inputs?
m times. Yeah, m times. Oh, yeah, I'm doing it correct. Okay, so okay. That's that's explainable. Okay. What?
Oh,
Sorry,
hello, what's
sorry.
happening?
Sorry. Just my shortcuts.
Oh, okay.
Okay. Uh,
Okay,
okay. So
so
maybe
let's
it
pause
would.
again.
Yeah,
Because, okay,
yeah.
I think what happened just now is there are two tasks that you have to do. First, you need to read the inputs, and then you need to actually solve the problem. But you're thinking about both at the same time, right?
Okay.
So first, I want you to think about what task am I solving first? Am I reading the inputs first? Okay, let's do that. Am I solving the problem now? Okay, let's do that, right? So what are we doing right
Mm,
now?
okay. So we need to. Okay. That's correct. We need to read the inputs. I would store it as a vector of pairs. Okay.
Okay.
This is how you do it? I don't remember. Yeah, I don't. I think so. Uh, how to call it? Maybe LRs of size. I think so. Uh, so LR. Okay. Uh, so I have read the inputs. Yeah. Mhm. I need to learn how to use my keyboard first.
Okay.
Yeah, I think you are set for the reversing the array.
Okay.
Yeah, I don't know really how to do it.
Okay, for now, just so we get an understanding of this problem, I want you to pretend there is a reverse mat. You can create a function, but like not fill it in. Pretend it exists.
Okay, yeah.
Yeah,
Okay, okay. That's a idea.
yeah. So just create the function, write the signature, but like leave the body empty. Just pretend it exists for now.
Yeah, okay. Uh, maybe I don't yeah, I coded too much in C++. Maybe code it left and right. I can just do it like this, yeah. Yeah.
Sure.
Mm. Yeah, and I think that would work if the mm, yeah, I need to do that n time. Yeah, I need to do that n times, not k times, right? Need to have another loop. I think so. This would be k. This would be um. I think that would work.
Okay. So a few things. Line 34 and line 35. Why is that indexing zero only?
Oh, my bad, my bad.
No, it's
It's
okay.
J.
It's J, okay.
Yeah.
How about lines 43 and 44?
43, okay. Yeah, it's it's also my bad.
No, it's okay. Okay, so one, I noticed you have an autopilot. I think it's like a bad habit. You keep writing index zero.
Yeah,
Okay, so whenever you write index, I want you to tell yourself, what should I be indexing? When you write zero, I want you to stop and think, should I be writing zero? That's
okay.
you have to download that idea into your brain. Okay, so I want to reflect about what has just happened. So writing, okay, so like problems like this are not easy. They're not easy. They're difficult because usually they're mixing two ideas. Usually that's the obvious idea, but to actually solve the problem, you must apply some problem-solving technique to translate the problem to a similar one that solves it faster, right?
Yeah.
That's the hard part. That's okay, that already is difficult. And then you have to program it out. That's another layer of difficulty. But in our case, we simplified the problem. I told you, don't worry about making it fast, just do the obvious solution. That should be very easy. That should be like you should be able to do this in less than a minute. Okay.
Yeah,
So I want to talk about a few things while we are here. First, in this kind of problems, right, I want you to separate the steps. I want you to separate solving the problem from what I call parsing the inputs.
parse. Okay,
What does
yeah,
parsing mean?
like getting the input. Yeah,
Getting the
like
inputs, but
and
in a format,
storing them.
yeah, but storing them in a special way. You want to store them in
Yeah.
a way that's convenient for you so that you can operate them in a manner that's convenient and ideally performant, right?
Okay.
So when you're solving these problems, I want you to separate these two ideas. I want you to first, am I parsing now or am I solving? And here's the thing, to
Mm.
solve the problem, you need to parse first. Because if you don't parse, you have no data to work with, right?
Yeah. Okay. That's a great tip. Thank you.
Yes. Uh, Second thing is I noticed that you don't solve the problem in order. Like for example, in line 37 to line 48, 49, sorry. I noticed
Yeah.
you wrote the inner for loop first, and then it's like, oh wait, I have to iterate through k first. So then you
Mm.
wrote the second for loop, right?
Yeah.
So this problem is small, so you can do that. And maybe in competition, maybe it's better to do that. But in my opinion, I think most of the time you want to solve it in order, actually. Like it's better to write the outer for loop first and then the inner.
Okay.
But again, like I may be giving you advice that's bad. Maybe in competition you wanna like you might want to do the opposite. So that
Yeah.
one
I
you
really
have to
don't know. I haven't been in competition yet.
okay. So okay, whatever I say, you must take it with a grain of salt. Like I say, like programming for like industry is very different from like competition.
Mm. Yeah. I know that.
Uh, Second thing is oh sorry that third thing is okay. This is my opinion. Try not to repeat uses of variables. So notice like line 24 to 27, you use I, and then line 37 to
Mm-hmm.
line 47, you use I again. Now, most of the time is okay. But I, in my opinion, I think that's dangerous because 99% of the time you do the good thing, you do the right thing, but 1% of the time you might make a mistake, right?
Okay.
So this is my personal opinion. Not everyone does this. I would use the lowercase letter. So for example, like line 24, you use capital N for the thing you're looping through, right?
Yeah.
I will use lowercase n instead of lowercase I.
Okay.
But again,
That's a
that's opinion. That's like not everyone will like that though. So you know you can judge for yourself. Okay. All right, so that's all my observations for now. Next thing I want to ask you is I don't know if you do this in competition or if they train you to do this, but do you do the asymptotic analysis,
what?
big O
I
analysis,
big what?
big
Big
O?
O. Yeah.
Have,
Yeah.
could you give me a big
Like.
O analysis of this algorithm?
Uh, Okay, so I think this is O of n, and this is O of n like squared. It's uh, quadratic, yeah, I think, right now.
Okay, so is that was technically it's O of K, right?
Okay, yeah.
O of K times M, but is it just quadratic?
Tax, yeah, yeah.
Okay, so notice we have three variables, right? It's not all just N, there's N, M, and K. So
And okay,
line 24 is definitely O of n, right? You're looping through, you're looping
yeah,
n times. Line 29 is O of m. You're looping m times. Um,
yeah. So
Line
it's
37 is k. For each k, we're doing m things, so it's k times m, right? Is that
it's
it?
like
Are we done?
that.
Is that it?
Mm, yeah, I think so.
Okay, there's one more thing we're not considering, which is line 46, reverse.
46. Yeah, okay.
What's the big O of reverse? Do you know?
I don't know.
Okay,
Like,
so it actually depends on the implementation.
mhm.
How would you Do you know how a reverse function is made? Do you know the implementation?
I don't think so. Not. No, no.
Okay. I'm gonna just Google it for our purposes. I believe it can be done with O of n, but let me see. Oh, yeah, O of n. Okay, for now, you may assume
Okay.
it's O of n, where n is the length of the list.
Yeah, okay.
So what's the big O of our reverse here?
Mm, like it's also we go of n, yeah. We go of like the length of the yeah, yeah, n. Yeah, sure.
N. Is the length of the
Yeah,
list n?
yeah. Is it not?
No, no, I'm asking you. I want to make sure
Ah,
that you understand it.
yeah, yeah. I understand. Okay, okay.
Okay.
So like it's all of n in the worst case, yeah? Because in the
For
worst
reverse
case we need to,
specifically. Yeah.
yeah, yeah.
Okay. So
We because we yeah.
okay, now that we know the big O of reverse, how do we factor this into our final big O analysis?
Mm, oh, so it's O to the third power, yeah,
Can you undo a bit?
yeah,
Can we get back our letters? Okay, so I prefer not to use. So notice how we have three variables, n, m, and k.
yeah.
We don't want to mix them. So this is good. Just now when you combine everything, that's
Okay,
not good. But remember how we said the reverse is bigger of n? Ah, right. So that's where the n goes, right?
yeah, okay,
Okay, so I'll tell you right now, this is probably not the answer. This is too easy.
yeah. Because uh, this would be like too much, yeah,
Yeah, and the n plus m is can be removed, right? We can ignore that because the k times n, we say it will dominate the runtime.
yeah, yeah.
Yeah. Okay. So one thing about big O analysis, don't just think about the for loop. You must think about what's inside the for loop. Okay?
Mm,
Very common mistake. The reason why a lot of times when you see like people doing competition, they ignore the insides of the for loop, it's because the for loop has constant time operations. Okay?
okay, so we can
Constant.
ignore like O of one, yeah.
Yes, exactly. So line 43 and 44,
Okay,
that's an example of constant time operation. It basis for all purposes that basically doesn't exist.
okay,
Okay?
okay. Thank you, thank you.
Yeah. Uh yeah, so that's the second thing. When you do big O analysis, do not forget to look inside the for loop and look literally each and every line. Line 41, line 43, line 44. Ah, line 46, reverse. That matters a lot. Okay?
Mm-hmm.
Okay. Now my next question for you is we have just done the obvious solution. Do you have any ideas of how we might improve this solution? Any tricks we can
Uh,
pull?
uh, okay, so definitely we don't have to do this k times.
Okay, why
Mm,
not?
why not? Because it's cyclic in some kind of way, yeah.
What do you mean by
Mm,
cyclic?
okay, so like if we have an array, I don't know, one, two, three, maybe we should comment that. I think that would be great. If the like if this loop just swaps these two numbers, yeah, so the array would look like that. Uh,
Okay,
s- so the next iteration, like the array would be same as no iteration, yeah. So the array won't be affected, and it would be like a cycle of this, yeah.
okay,
Sorry, I think that's how it works.
okay.
Like
Yeah, yeah,
in
keep
math,
going.
in permutations.
Can you show me some more? Can you continue this example a bit more?
Yes. Uh,
Okay, I think you already got the idea, but I want to see it.
yeah, yeah.
Yeah.
So that's like k equals 0 and so on, yeah.
Okay.
Uh, yeah, I think that's
Wait.
it. Yeah.
So k equals 0. Okay.
If we
What
do
is m here?
nothing, uh, what?
Sorry, what is m here?
M?
This example you're giving me, is this example of the problem, or are you just showing the cyclic nature of reverse?
Uh, yeah, I'm just talking about the cyclic nature. Yeah.
Okay, sure.
Okay.
Can you give me the same explanation, but for the context of this problem? How might we apply this to this problem? Can you give a small example?
Mm, I think that's the example. Like if the like in the best scenario, the m equals 1 and we swap like these two numbers, yeah?
Okay.
But if the m equals, I don't know, like 3, if the numbers swapped is different, yeah, I don't know how to approach that. Like if we swap, I don't know, the first two and the second, like is okay. If they swap first two and then the uh, second with the third, would be like that. Sorry.
So I
Uh,
need to pause you for a second. I need to give you a new Zoom link.
yeah, of
So I'm
course,
gonna
of course.
I'm gonna close out this one, send you a new link on Gmail, okay?
Yeah, of course.
Or I'll see you in a minute.
Yeah, just yeah, okay. Uh,
Yeah, so the reason why I say that I'm not saying the reason why I say this is not an example for this problem is because I'm only seeing one integer. But cows, they have pairs of integers, right? Where are the pairs?
yeah.
So yeah, I want to see that as well in our example.
Mm, so we swap the first and the third. I think it's in the problem. Uh, wait. Yeah. Okay. So it's not by indexes, it's by like the position. So 1, 2, 3. Yeah. Okay. Uh, so mm, what do we would swap? I think I don't know how to approach that really. Uh, so maybe these two again. Uh, okay. So we swap these two and first. What just happened? So. Mm. What did I do wrong? Wish chasing. Sorry, no Polish. I did something wrong here.
We can ask line 56. Why is it 3214?
What?
Line 56. Why is it 3214?
3214 because this is like the example of changes from 1 to 3 from first to second, from second to third, and from second to one, like position wise. Is it not correct?
Wait, hold on. Let me read the problem again.
Yeah, of course.
Because I don't know if it's two. I don't think is 2 1 a valid pair? Because two is greater than one, right?
Oh yeah.
So yeah, you make sure that
Okay.
when you create examples, they follow the constraints of the problem.
Okay. Okay. But okay. My mistake.
No, it's okay, all good.
Yeah, yeah. It's like the ranges, yeah. Sorry, sorry.
Yeah. And the second thing is that if the range is from 1 to 2, that means two cows should be reversed, right? Not three.
Yeah, not three, but we reverse them later, yeah? Like we need to do three operations, yeah, on the same array.
Oh, wait. So line 55 to line 56, is that like all the three, like, line, it's like three reversals has happened?
Yeah, yeah, like yes, yes, that's
Okay.
right. Okay,
Okay, I see.
but
Wait, and
I
line
didn't.
57,
Yeah, we
line 57,
didn't.
why are there two threes there?
I didn't do it yet. Yeah,
Oh, okay, okay,
sorry.
sorry, continue,
Yeah,
continue.
yeah. I just forgot the problem. Yeah, and I thought that we need to swap two numbers. It would be too easier. We need to reverse the whole like array from the indexes. Yeah.
Okay.
Mm. So from the first, it would be like this. From the second, it would be like this. And from 1 to 4, it would be just reversed. So 4, 1, 3, 2. It would be like, yeah, k equals not 0, but 1. Uh, yeah, and from 1 to 2, so it would be like 4, 1. And from 2 to 3, it would be like this. Yeah, and I can keep on doing this, but I don't know where it would be. It would just go to the default position. That's the main question, yeah? I think so.
Okay. Yeah, I
Yeah.
think you got the idea. Okay,
Mm-hmm.
so I'm gonna explain my understanding, then tell me if I'm wrong. So if we look at line 55, if we look at where that one is going, in the first position,
Mm-hmm.
that one goes to the second position on line 56, right?
Yeah.
On line 56, if we look at that four, we see that four goes to the
It
second
goes,
position.
yeah, yeah, to the,
So
yeah.
in every position has a fixed next position, right?
Mm-hmm.
That's what you're trying to tell me.
Yeah.
Which means all we have to do is compute for how do we find the next fixed position for each position once, and we can reuse that k times, right?
Yeah.
So that means we don't have to perform the reversal so many times, right?
Yeah.
So okay, so this is a mathematical trick. Okay, so I'm not gonna ask you to implement that, but I wanna again review what we have done. So
Mm-hmm.
okay, ideally in a competition, you probably should do this first, right, before actually solving it. And
Okay.
I think you had this in mind, but I feel like you also had I think like the blank page syndrome. You have like an empty page and you don't know how to begin.
Yeah, definitely.
Okay, so okay, I'm gonna give you some words of wisdom, okay, and I want you to remember it for life.
Mm-hmm.
The first thing that you should do in a problem is first understand how do you encode the information. So I don't know if you remember the Reddit post. My pedagogical approach, the approach I take to teaching computer science, is based on two books. And these two books, the fundamental principle of programming is that our job as a programmer is to turn information into data, encoding information as data, right?
Yeah. Okay.
So in a normal session, I explain more of this, but I'm gonna go past it for now. So the first step is you need to understand how does information become data? How do we represent the information as data? Okay. So in your
Yeah.
case, you chose a vector, you chose a vector of pairs, like many ways to do this. So that's the first thing. The second thing is I want you to create examples of the data representations. So what we're doing now is sort of like examples, which I think is good enough for our purposes, but you need to understand how they get encoded.
Mm-hmm.
Um, so next is examples. And you want to really think through the example. So what we're doing right now is very important. If you're like really like those people who are like gold Olympiads and at like computer science competitions, they run through examples very quickly.
Yeah.
Yeah, so you need to like develop that skill. Like right now we are writing it out. There's a way I don't do this, and in industry you shouldn't do this, but there's a way of like going through all these examples in your head without writing it out. Um, but yeah, it's good to think through examples, especially for practicing. It's good to work through examples. Usually the answer reveals itself when you think through examples. Okay,
Yeah.
so that's the third step. So to summarize, how do you encode information as data and work through examples?
Okay.
For coding competition, usually when you work through examples, you will find a mathematical trick. For example, here is the mathematical trick. When we perform, we only need to do line 55 to line 56, right? If we can figure it out, we can figure it out for the rest. So that's a mathematical trick. In all problems, in competitions, there's probably a mathematical trick like this one. Maybe there's more. Okay.
Yeah. Okay.
Um, After that, so that's the information, that's the data sort of things. Next is functionality. How we have this frozen picture of data, of information. How do we do stuff with it? How do we compute on it? That's the next step. Next, I want you to be systematic on how you perform the tasks. I want you to be able to write down in English or in Polish, in natural language, what are the tasks that my function must perform to solve the problem. Obviously, the first thing that you must do is parse into your chosen data representation. Next,
Okay.
next is like, it will depend on the problem. So for this problem, you might say, oh, we need to figure out one iteration of reversal to figure out the mapping from current fixed position to next fixed position. And then I will loop through k times applying this same mapping until I get the final solution, and then I return the solution. So that's an example of fixed steps, right?
Okay.
All right. So right now, this session is more like a calibration. I don't think you learned much. I guess you learned some tidbits here and there. But like if I gave you a
Yeah.
new problem, you're probably gonna have a lot of trouble again. So
I think
if you
so.
do
Yeah.
come back for more sessions, I think my goal for you is probably for you, I'll probably skip a few steps. Usually if I start with someone, I go through like from the absolute beginning. For you, I think you are a bit more advanced, and I think your goals are different from everyone else's. Um, so for you, I'll probably give you more algorithm design. How do you think systematically through algorithms?
Okay.
That is probably my goal for you. Um, if I were to have more sessions with you, I will, and also like the skills I train, I don't, most of them may not be directly applicable to competition, but I think it will still be good for you. It will train your thinking.
Okay.
So it will be
That's
good.
my
Yeah.
like my main goal right now.
Okay. Okay. We have a bit more time. I might be able to show something first. Okay. Let me first ask you, do you have any questions so far?
Uh, like to the session, I don't think so. But about booking the next session, uh, does the week count as like this one, or like do I?
Monday to Sunday.
Uh, uh, yeah, yeah. Okay.
So
So
you can book
I
next Monday, for example. Yeah.
okay, okay. Thank you. That was my question.
Yeah. Yeah, and you can use the same booking link.
Yeah. Okay.
Okay.
I know that. Thank you.
Okay. As for what I would do, okay, I need to do more thinking as to what I'll give you. But like in coding competitions, do you all do recursion?
Uh, like I started learning for competition like okay like 1 week 2 weeks ago when the vacation holidays started in Poland because in school we don't learn about this and I didn't have anyone to taught me this to teach me this, yeah,
Okay.
so I'm just on my own learning the algorithms.
I see. Okay. Okay, let me think about it. Can you show me some of the tree problems?
Uh,
Oh,
yeah,
tree or
but
graph. Yeah.
they are more in Polish definitely. I just learned
Oh, no, I just want to
about
see the code. I want to see how you, or like, ca-
okay,
yeah.
yeah. Mm,
Actually, yeah, I prefer to see trees.
trees.
Yeah,
I
if you have a
think
tree problem.
this is a tree problem
Okay,
with but it's with pre and post. I don't know how to say that in
okay.
English.
No, no, this is
Yeah,
perfect. This is perfect.
yeah,
Pre and
okay.
post is English.
Yeah, yeah, I know that,
Okay,
but
all right.
I don't know. Yeah, yeah.
Okay, remember I asked like, oh, do you do recursion? So this DFS function in
DSS
front of us
is
is
recursion.
recursion.
Yeah,
Yeah, because
yeah,
it
I
calls
know.
itself, right? Okay,
Yeah, like I did a lot more code in Python, so I'm also in the programming class, so
okay,
we need to know this. Yeah.
okay, yeah. Um, Let me ask you, why does does depth first search need recursion? Is it necessary for depth first search to have recursion?
Uh, yeah, I think so because uh, yeah, we in the end we need to get to the like the point where we started out. So uh, I don't know how to say that. Sorry,
No, no,
but
I understand what you're saying.
okay,
Um, what if I told you
definitely,
there's a way to implement depth first search without recursion?
okay, but with this problem, but I don't think so. Like
Okay.
definitely we can do the DFS without recursion. Mm. Yeah, I don't know how to do that. You can show me how
Okay, so I
to.
think I'll probably I don't know how many sessions we're gonna have, but like if we have to have many sessions that will come at some point, I'll show you how to implement depth first search with recursion and without recursion.
Okay,
And without recursion, like if we don't use recursion, one must compensate for that, right?
okay,
Okay, okay, but that's future us. I think I
yeah,
have an idea of what to give you. I need to do more thinking. So I think you are a special case for me. Your situation is very different from everyone else's.
okay. So sorry
Uh,
for
no, no, don't be
making.
sorry. No, this is great. Like I love the challenge. Uh, okay.
Uh, that's too bad. We can only have one session per week, but yeah,
Actually, I was thinking of more ideas because like I have a lot of openings in my slots now. I was thinking about more ways to open up more sessions. I'm gonna send
really.
out a new email on Sunday to talk about how I might change things.
Okay.
Well, we'll
Like
see, we'll see.
if you started to like if you wanted to like get money for these sessions, I'm willing to pay, really.
Okay, all right, I'll write note of that. Okay, no, but for now I'm doing it for free because I don't know how long I'm doing this
Okay.
for, and also like I'm like I just graduated from college. I'm looking for a job right now, so
Mm,
like I'm in this situation where like I can't really make money from this, but we'll see, we'll see.
yeah, okay.
Um, okay, okay, we got 4 more minutes. Let me see if I got more questions for you. Can I see some of your graph problems?
Graph problems. I
Yeah.
think I uh, have like I don't know where these are. I think this is yeah, for sure. This is graph problems when I had to check whether the whole graph had only it was only a cycle.
Oh,
Okay,
yeah, okay. Oh, there's a name for an algorithm for this. I forgot. It's been a while.
really? Okay. I
Yeah.
like uh, I made a DFS algorithm to just search if the like the I don't know how to search. It's a matrix, like the main part of the graph. Like the we have node, like I don't know, like the
Yeah.
circle in a graph.
Yes, yes, it's called node. You're correct.
Yeah, okay. So if the node has two neighbors, I don't know how to. Yeah, and if it doesn't, it isn't a cycle. Yeah.
Okay. There's a sporady zone. What does that mean?
Well, this checked
No,
is it's checked in Polish.
checked.
Okay,
Okay.
checked.
So
Yeah.
if you saw something that you have checked before, it probably means that's a cycle, right?
Uh, what? Sorry.
So let's say you checked something already, we saw a note,
Yeah.
and then we see it again.
Yeah.
Would that mean that we found a cycle?
Uh, I think so.
Okay. No, no, I'm just asking. I'm just checking your knowledge. Yeah.
Like this was, I think, a problem for from the uh, code forces. Yeah.
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 I
Yeah.
finding cycles in graphs is a very established problem in computer science.
Yeah. It had an explanation when the graph is a cycle. So it was quite an like easy one because we had so much information to
Hmm.
work on.
Okay, I have to wrap up here. Okay, so I'd like to end my sessions by always asking to the student, what is one thing you learned today that stuck with you?
Hmm. I think like to separate the part of getting the data from the part when from the working on problem solving. Yeah, I think that's the main part of
Cool.
things you have told me.
Nice. Okay, great. All right. I'm
Great.
very happy to be able to help you in the way ways I know
Yeah,
how, and
thank
I
you
hope to
so
see you
much.
again.
I hope to see you again too.
All
Bye.
right. Bye bye now.